Welcome all to my talk. I'm talking about looking at sentences as a password. First, I would like to say some words about myself. I got a master's degree in science on IT security in the field of network and systems. I did my master thesis on the topic improved guessing on composite passwords. My supervisor was Markus Dürmuth. As far as I know, he will talk later today as well. I'm currently working as an in-house pen tester in Germany for an insurance company. And I would like to make a short disclaimer. This presentation has nothing to do actually what I'm doing for my employer. It's completely my personal opinion and it's based on my master thesis. During this work, no computer and no personal data were harmed in any way, meaning all research I did was with no connections to any person at all, meaning no user accounts. It was just about passwords, and I used the link from Rocky Physics. Yeah, about passwords, some word. As we as a researcher and pen testers request from our users that they are using passwords which are hard to guess and which therefore should be somehow long. Usually we request them to have 10 or 12 or even more characters for their password. And we ask them to have at least 3 out of 4 classes on their passwords. And that makes them hard to remember, and our users have to find some solutions to remember their passwords. One of them could be writing it down, which is very bad because this slide of paper you will lose, or you will put on your monitor, and therefore, well, we as a pen tester have it somehow easy to guess these passwords. Other reuse their passwords, which is, from my opinion, even worse. Passwords are leaked. There were a lot of recent leaks in the last years, starting with RockU in 2009, going with Sony and LinkedIn and whatsoever. If users are reusing their passwords, for sure we will find them on the internet. Which makes our work as well very easy. Other people choose very easy to guess passwords, like the name of their wife, their kids, their dog, combined with some other data maybe. But this is all something you can find on the internet, on Twitter, on Facebook, sometimes even on Zing and other websites. Now, some researchers started to suggest that the people should use sentences or combine their passwords out of several words. That's exactly something we are going to look at. But let's first talk a little bit about leaks. My work based on the leak of RockU. RockU was founded in 2005. They started to integrate games on Facebook in 2007. They got hacked in December 2009, and around about 32 million passwords were leaked. These passwords were stored in clear text, meaning we didn't have anything to do to get the real passwords. not as usual, like they are hashed, and we have to really guess them, which this makes it a little bit comfortable for us to do some research on. We found out that the minimum requirement was a size of 5 characters. But that's not all. The users from Rocky were asked to give their passwords for social networks. For example, Facebook, MySpace, and so on. And they were told, well, we will not store them. And that was actually a lie. The passwords were stored, which makes it even more interesting for us to look at them. I have here some examples of passwords which are in them. The first one is the top 1 passwords, 1, 2, 3, 5, 1, 2, 3, 4, 5, 6. Other passwords which made us a little bit curious were I love you, I love many, Blue Devil, I hate you, one, and some other passwords which were clearly combined out of several words. And then at some point we saw, oops, there might be sentences, there might be something interesting to look at. So we thought about ways how someone would or could track the passwords at all. So we thought, well, what's coming usually to mind is doing some brute force, and we would get fast and early results, and well, it would be reasonable for passwords, let's say up to 10 for our equipment, 12 for NSA equipment or so. But if users are choosing sentences, they are getting quite very off. 20 or so characters would not be a problem for a sentence. So we thought about, what about rainbow tables? Well, rainbow tables are very good if you want to track a single password. But as I found out on my equipment, it took, let's say, 2 or 3 minutes to track one password, which makes it not very good if you have a big leak. So 2 minutes, if you have 32 million passwords, you wouldn't come to the end. Also, rainbow tables are good if you have a very, let's say, a limited number of characters. If you are going past 8 characters, these rainbow tables can get very huge, making it very uncomfortable to go past these 8 characters. So the next attack would be a dictionary attack, which is usually good and fast, but there are some limitations. One limitation is the size of the dictionary. You can more or less only track passwords which are in your dictionary. You can do some transformations on these passwords, but still, if you have a combined word, this combination has to be in your dictionary. And usually you don't have sentences in it, and you have only combinations you already have seen in your in other leaks or in already tracked passwords. So what about sentences? For me, a sentence is not only a sentence in a grammar context, which means clearly I love you is a sentence, but a password like Mike is, in my opinion, also some sort of a sentence, not a grammatical sentence, but a sentence I'm trying to track. Therefore, I decided for this work to completely ignore grammar, meaning I didn't try to build any real sentence. I would have to do a lot of more work on it at this very low success rate. So I started to think about a new approach and a new way to track longer passwords. Longer passwords which are combined out of words, which are usually not in any dictionary, and which we never have seen before. It's quite interesting to look at sentences they are doing there. So for my approach, I started to think about the requirements. I wanted to start with a set of passwords, which is already leaked, and use a dictionary. I will come later to it, which one I took. Then I decided to do some analyze on each password with respect to the words in the dictionary. Meaning I tried to take passwords and cut it into words which are in the dictionary. Therefore, I tried to learn how users are combining their words, but only based on the size of the words. From this, what I learned there, I tried to improve as a given dictionary and get some additionally success rates there. For the requirements, I used as a set of passwords, as I mentioned, the Rocky leak. There were some other leaks I was looking at, the MySpace leak, for example, and sometime after I finished my master thesis, I was also looking at a number of hashes which were published via torrent and Twitter on the internet. There was something like 149 million passwords leaked there and only available as hashes. Some people very fast said they could track 122 of them, and then I tried my approach on it, but I will come later to it. As the dictionaries, this was one of the hardest part I was looking for. At the end, there were 3 dictionaries coming to my mind which would be somehow reasonable. The first one is from Project Gutenberg, which is a website which makes text which is in the public domain available to the users. So we can find there a lot of books like Shakespeare and so on, where no copyrights are on them anymore. Another source for a dictionary I was thinking about was Wikipedia. As we all know, Wikipedia is a big encyclopedia which is quite growing. I was assuming that the words which are in Wikipedia are somehow also used as passwords, at least combinations of them. And the third dictionary I was looking at was the dictionary of iSpell. But let's have first a look at the Gutenberg and Wikipedia stuff. I downloaded the complete books and texts from the internet. They were available at Gutenberg and Wikipedia as the sites of them, and did some cleaning up. For Wikipedia, it was most times that I have to remove the XML stuff, which was quite annoying. And for Gutenberg, I had just to remove some signs like question marks and so on. The next step was to cut the text into words and to count them. After counting them and looking at them more closely, I saw that there are some words which I wouldn't expect as a password. For example, there's a Wikipedia article about a computer game which has around 20 A's in the beginning in various capital letters, and I have assumed that such a password is so unlikely that I wanted to remove such words. And I did some more investigations and found out that a threshold of about 200 is very reasonable. So if a word was appearing less than 200 times on the site, I simply removed it from the dictionary. At the end, I had around 210,000 words, which were quite good. And we will see later what was coming out of it. The next dictionary I took was the Eisbahn. This was quite simple because it was a dictionary of a spell checker. I hadn't to do any cleaning. There were simply the words inside. For some convenience, I added a list of names I found on the internet. So I ended with around 140,000 words. So the next part of my work was that I had to analyze the passwords we were having in the leak. I took each password by itself and started to isolate sequences of letters. Some passwords had some lead speak in it. Some passwords had in the middle something like numbers, dots, and everything. To keep the analysis very simple, I had chosen to simply ignore these signs and cut the words at this position. By this, I tried to identify the words I found, or let's say the sequences I found in my dictionary, and tried to cut them further into words, trying to match a most big size on it in the beginning. So I started to have to look at the complete sequence if it is in my dictionary, then divided this sequence into two parts. One was constantly growing, the other constantly shrinking, and as soon as I could identify the words in both sequences, I was done. So at the end, I ended up with something like you can see here. All the I love you examples. I found the I as one word, the love as the second word, and the you as a third. And I saved this result for the rule leak. So, as I mentioned before, there was some lead speak in it. And I want to say something about lead speak with respect to the analysis. And I want to do it with a short example. I found in the Rocky list word like perhaps with two exclamation marks. And when I looked at it first I was a little bit curious about what it could mean. So I looked up for the word PAPS, which was a financial time. Then we had to explain exclamation marks. Then I thought, okay, what could it be else if you are looking at lead speak? It could also be Pepsi, which is a soda, with one exclamation mark. And it could be Peps with an exclamation mark and an I, or Pepsi with an I at the end, which brings us to the possibility that we have either a word with a Roman 2 or a soda with a Roman 1 or an I. So I decided to leave this lead speak out, especially if when I got a word which had around 30 exclamation marks, and I had to try to find all possible combinations in the lead speak. So at this point in time, my computer crashed, and it wasn't very funny, so I decided, let's leave speak out of it. So after my analysis was done, I started to create a new dictionary with the stuff I learned just before. Therefore, I loaded my analysis and did some calculation on it. I knew how many words I could find with one of these sets of data I got. For example, with the I love you, this 1, 4, 3, I had a certain number of words which I could track with it. And on the other hand, I knew how many words I had with 1, 4, or 3 letters. So I calculated this sequence, how much possible words I would create out of the sequence, and set it into relation to the number of words I could track. Afterwards, I sorted it, and in the way that if I could track more words than I would generate, this got a higher probability of usage. So at the end, I ended with an enhanced dictionary. When I started, the dictionary was something about something like 100, 200 megabyte. And at the end, the latest dictionary was around 50 gigabyte. 120 megabyte and 50 gigabyte. So I started to simulate tracking of this leak. I didn't have actually to track it because it was already clear text. But I wanted to see how good would my approach be. So I used the word from Matt Weyer to learn patterns on the leak and use this to track actually the rock queue. I applied these patterns to the words and checked if these new words were available in this leak. This is one of the results I got there. It's a little bit hard to see. I'm trying to show here the differences of several approaches. One of the approach, the iSpell only, was that I took this iSpell and run it against the Rocky leak. The next approach was with the work of Matt Weyer, which got some better results actually. And the latest test was with my approach, with a new dictionary and with with the Medwire algorithm. What was interesting is that the iSpell and also the iSpell with Matt's approach got very fast, very good results. On my approach, for a long time, I didn't get any improvement. You have to consider here that it's a logarithm scale, and actually between these lines here, there are around 5 to 10% difference of tracked passwords. So to make it more visible, I did my approach also with different dictionaries I used. The Johnson Ripper is, that was what Johnson Ripper is putting out with the Markov chains. And the iSpell and the Wikipedia are my dictionaries after modification. What you can clearly see here is even that Wikipedia has much more words in the beginning. I had with my iSpell a much bigger success rate because, well, I had to cut at some point, and with the iSpell stuff, I had simply more combinations in it. So, last but not least, I would like to have a look at the 146 million passwords which were announced on Twitter at the beginning of the year. Several researchers tried to break them. One of the most successful succeeded to break around 122 of them. And which was very good, actually. Then I took his passwords he found there, tracked his passwords basically, removed them from this leak, and tried to run my approach on it. And I succeeded to have additionally around 5% of the leftover passwords, which is not bad in my opinion. So, to come to a conclusion, what I'm trying to show you is a new approach of improving dictionaries. With this approach, we can get between 5 and 10% better results. It's highly depending, of course, on the number of combined passwords and sentences in the link. I will publish my source code somewhere in spring 2013. I have to do some cleanup there, and it's quite messy still. But it will be available on the internet together with my master thesis. And now there will be some time for questions. I even have my email address over there if you have further questions afterwards or want to contact me. Unfortunately, I have to leave tomorrow and will not participate longer than today on this conference. So feel free to ask questions, send me emails, and thank you.
Okay, questions for Norbert?
I do have one.
Yeah.
And, you said you cut the words to get 210,000 of results, so you cut it and compared to the Wikipedia. How did you cut the passwords?
The 210,000 words, which were from the Wikipedia, I assume that's your question, how I cut it Wikipedia, right?
Yeah.
As a delimiter, I choose basically spaces and some signs like dot, comma, and so on.
Okay. So that's the way how you get the original, let's say, root password text or
Yeah.
word from the list. Okay.
Yeah. I counted afterwards them and created a threshold to reduce some rare words.
And when you release your code, will it be part of it?
I can make it, yes,
Okay.
of course.
Okay.
But I would like to mention that there might be a better dictionary right now. What I found out after my master's thesis is that Google did some analysis on their books they are scanning. And they have a list of so-called n-grams, which means they have a list of simply the words sorted by language, and also word combinations with 2, 3, 4, and, if I'm not wrong, 5 words. But this is then already getting very big.
Okay. Thank you.
More questions? Okay.
Number maybe some more details about this threshold of 200. What made you to choose this?
Yeah, I was very close looking at the words and wanted to exclude some certain words. Mainly, I wanted to exclude words which are very small in the size, because if you have a dictionary where every combination of 1, 2, and 3 words are in it, and then you do the analysis, you will for sure succeed in finding any password and find any combination of these words in the password. But the problem is you then don't have really words, because if you have, for example, a combination of WW, it's not quite a word I would expect. So I did a close look on the resulting words, and especially on the words which had a very small amount of occurrences. And it was more like a sum of rule of thumb. Yeah?
How many combinations of words did you end up in word list in the end? Was it 2, 3, or 4 word combinations? Did you put threshold?
Okay. I decided to go no further than around 10 billion words at all. So the size, how many words were present, was decided by the algorithm itself. Meaning it did some calculations which combinations are more likely and which are less likely. And the more likely it was, the bigger size it at the end was, because I had a very low number of combinations how to create, for example, 20-letter words. It was more or less to 10-letter words, something like this. And these 10-letter words were already a very small number in my dictionary. So it was at the end more likely to have very big words, but the amount of them was very small. Words with the size of 8 to 9 characters, it just started to be in this dictionary at this border of 10 billion passwords. 10 billion words, sorry. Yeah?
And did you put in spaces in between words?
No, I just put it words together. It would for sure be a good or another good approach to put spaces in between, especially to enhance the transformation algorithm for creating the actual words. Because if you have space in between, you can say, okay, the space I will replace with a dot, a number or something like this. I'm trying to enhance this on the software before I will publish it. Yeah?
Are you familiar with the NIST formula for estimating the entropy in an English sentence? And how does, if you are, how does your work compare to that?
Yeah, the question is if I'm familiar with NAST? NIST.
Measuring entropy.
Yeah, measuring entropy. I read it, and I was discussing it during my master thesis with my supervisor. I personally think that this entropy is good for English text and for cryptographic at all. But it's somehow useless if we are going to look at passwords. The reason for this is the entropy of a password is not the same entropy as we have in an English sentence. For example, the word 1, 2, 3, 4, 5, 6 has in passwords a very low entropy. And you can find much other examples where you will see that an entropy within this standard would be quite reasonable, but the password at the end sucks. So what I would suggest is something which is called guessing entropy. There are some papers on the internet about it. Other questions? Yeah?
Last one. Was this only done with English, or did you look at adding other languages in as well?
Since it was a leak of English passwords, I only looked at English words, yes. Afterwards, I tried to use the same results from the learning algorithm to use it on a German dictionary. The problem at the end was I didn't find any good leak to test against it. But if you have a leak for any language which has a reasonable size, I'm happy to take it and happy to experiment with it.